Hello, everyone. Welcome. Good morning, good afternoon, good evening. Depends on when you're watching this. Um, in this lecture, I plan on covering looping structure. Well, we didn't really get through all the loops, right, last time. Um, how you had to talk about the for loop, the while loop, do while, maybe switch statements as well, and then get into functions. Some of the examples that you might see, I think I might have mentioned it in the previous lecture. The cout statement. So two things. If you see include IOStream, that's a C++ library. Cout is a C++ library. So just ignore those for now. We're going to cover those again at the end when we talk about um, from C to C++. But outside of the cout statement, the syntax is the same. C++ is actually built on top of C. So whatever C has, C++ has it as well. And then C++ has more functionality. But I don't want to uh, get you confused with talking too much about C++. But look at the syntax of the loop. Okay. Okay. So now let's go ahead and start talking about while loop. But before I actually show you examples or discuss a little bit about while loop, there are three types of looping structure in C++. There is a for loop, there is a while loop, and then there's a do while loop. Then there are other ways of controlling the structure of the program or the control of the program via switch statements, breaks, etc. But those we won't cover. Um, I mean, right away. I'll get to it. But immediately, what I do want to jump into is the while loop. Um, then go ahead and talk about the do while loop, and then come to the for loop. Because I feel if you know about the for loop, first you'll skip the other two looping mechanism. That's what I would have done if I knew about the for loop first. Okay, so the way while loop works is the book calls it sentinel based looping. So while there is a so you this is what the syntax looks like: while, and then in parentheses there's a condition, and then there's the body of the loop, what you want to execute. Um, so in the while loop, you give it a condition, and as long as the condition is true, you're gonna stay in the while loop. You're not gonna come out of it. If you say I equals one, and then if you're checking if I is equal to one, then you never change I. You're always gonna stay in the while loop. Okay. Let me go over some examples here. Um, so here I have a program that's gonna print numbers from 1 to 5. Um, we start off I equals 1. If I is less than or equal to 5, then I'll put I. Oh, the increment operator. Makes sense? Um, and then you've got I thought I mentioned the pre-increment and post-increment. So what this actually means is I equals I plus 1. That's what this is. Okay? So in this program, I output I, and then I say I equals I plus 1. They continue in the same loop. I say as long as I is equal either less than or equal to 5, I'm gonna come in the loop. Okay, second time that's true. The second time when I come in, I is actually 2 because I incremented it, right? It says 2, and then I equals 2 plus 1. Now it's 3. Check the condition again. Is 2 less than or equal to 5? Yeah, it's still less. Then you output I. That's what happens. There you go. There you see the numbers from 1, 2, 3, 4, 5. Okay, so that's the while loop. Here, I'm gonna go through another example, and I start off int number. I declare a number, and then I have a sum. So this is a program to find the sum of positive numbers. So I'm going to keep taking the input from the user. I'm not going to do a whole lot of, I'm not going to do error checking at that point. Just going to take a number from the user. If the number is greater than or equal to 0, so the only check I'm going to do, I'm going to make sure it's a positive number, but nothing else. If that's the case, sum equals to sum plus number, right? So this. And then I ask user to enter a number, input the number, and after I've gone through the whole loop, the expectation is that I would know the sum at the end. Okay. What else should I point out? No, I think it's one more different. So I say number. The keyboard. My keyboard and computer is acting funny, but you get the point, right? Let's try. There we go. 2, 3, 4, 5, 6, 7, -1. There you go. So it kept asking me for a input until I inputted something that's not greater than or equal to 0. Basically, as soon as I entered a negative number, it exited the loop. Otherwise, it's keep going. 0, -1, and it stops. Okay, so the benefit of this is you don't have to keep you save number of lines of code, and your input and output is controlled, and it makes the code readable, right? Assuming you understand the shorthand representation of the plus equals 2. And as you saw from the textbook, you can use any other operator there. You just have to expand it in similar manner. So if you had sum minus equals number, then all it is sum equals sum minus number. So hopefully that program is clear. The next thing I wanted to cover was, remember I said I'm going to go over the while loop and then the do while loop. So let me show you what the do while loop does. The do while loop is slightly different. Is in while, first you check for the condition right away. But in do, you'll do it right away and then you check while. So you'll check the condition at the end. So in this case, as long as I is less than or equal to 5, I'm going to keep outputting I. And I'm going to keep incrementing I by 1. 1, 2, 3, 4, right? Keep going on. Now watch. One thing to keep in mind is I'm going to make this 5 on purpose. How about if I made it 6? See, 6 shouldn't satisfy the y. The condition is going to be false. But it did output 6. The difference between while and do while is do is going to execute the code. It's going to execute the structure of the loop at least once. And then check for the condition. Whereas if you had while in there, so if you replace this, see, while actually checks for the condition first and then goes inside the body of the loop. This is a slight difference between the while and the do while loop. Okay, so now let's go ahead and talk about my favorite looping structure
which is the for loop. And like I said, if I would have told you guys about this, you won't be so interested in the do while or the while loop. The syntax of the for loop is um, simpler, straightforward, and has least number of lines of code for any looping structure. You have your for loop, but in the parentheses, you declare a variable, you initialize the variable, you also have the condition check for the variable, and you also increment or decrement the variable. All of this in one line, right? So you had your, I still have that example up here. No, I don't. Okay, but you know, in your while loop, what would happen is you would have the int I equal to 1 outside of the loop, and you're going to be checking the condition as the condition in the parentheses of the while loop, and within the body of the while loop, you'll have the increment I. But here, you're able to do it all at once, which makes it very convenient. I'm gonna walk you through some examples. This for loop, it has int I equals to 1, and as long as I is less than or equal to the number, I'm going to keep looping, okay? And then I'm going to say sum plus equals I. So you should know this. Sum equals sum plus I. So I'm adding these numbers. Okay, and then finally I exit out of the loop, and I say this is the final sum. Now what's going to happen? So this is your starting point. I starts at 1, and I goes till a number. A number that's defined by you, the user. So you'll tell this loop how far to go. Go to 1, 2, 3, 4, 5, whatever, and then you're gonna keep adding it. And you're gonna keep incrementing it, and then in the loop you're gonna add. So you're gonna increment the sum. Sum is gonna be a running number. So I say 3 is equal to 6. Right? So you can run this in your head, and it's going to be a lot simpler. And like I said, this is probably the most used loop. I still use this. The do while loop and the while loop, I use it for teaching. While loop, I still use once in a while. But for loop is by far the most used loop and very convenient to use. Okay? So hopefully this is clear. Um, can you do it this way? What do you think? Syntax bytes, it's okay. What's going to happen? Infinite? There you go. It's not stopping. Because there is no condition over there. So syntactically you can be okay, but logically you're incorrect. Because you don't want to do that. You actually want it to have a value that's going to end your loop. The next. So that's all the looping structure. Now continuing on with our quest for control of the language and the way to control, the next thing up is a switch statement. Now the way you go about thinking or understanding a switch statement is a scenario based execution. Okay, so you say switch an expression. An expression is something the user might have entered, or an expression is something that you're testing against, and in that you have case 1, scenario 1. Okay, scenario 1, what do you want to do? And break. You break it out of it. Case 2, what do you want to do in that case? Or the default case. If none of the cases are valid or you don't run into them, you have a default case for whatever reason it might be. One thing to keep in mind is the break is a special keyword. I'm going to come to this in a little bit again. I think I have an example as well. So break is going to break out of the loop. Okay? So this is a scenario based structure here. So enter an operator, plus, minus, subtract, divide, whatever. I'm asking the user to enter in an operator, and then I say, hey, enter in, you know, two numbers along with it. So if I look at, it's a char operator, and then I have two numbers which are floating numbers, and then I have a switch statement on the operator. So if it's case plus, so if the user entered in plus, I'm gonna say num1 plus num2 equals this. So I'm adding, and then I break, out of the switch overall. Or if it's minus, then I subtract the two. If it's multiply, I multiply. If it's divide, I divide them. Or if none of those operators is something where user entered, I have the default case that the operator is it's incorrect. Let me run this. So I'm just gonna say, all right, because I entered in. Oh, I had an invalid input over there. Now let's be serious, and I'm gonna enter in plus two numbers followed. There's a space in between. So 1 plus 2 equals 3. Okay. So now you might be thinking, well, you could have done it via if then else, right? But if then else is gonna make it cluttered a little bit. Case is more cleaner and easily readable. But yeah, theoretically you can do it via if then else. Okay. What else do I have? Break and continue. Like I said, we use break, but I'll show you the example of it. Break, like I said earlier, breaks you out of the loop, whatever loop you're in. If, while, do while, whatever. Any type of loop, any type of looping, any type of control, and a break out of there. Continue will make it continue or go to the beginning of the loop again. These are two subtle differences between the two. So, look at this. I have a for loop that goes in from 1 to 10, and the moment I see 4, it says continue. And continue, what continue should do is it should take you to the very beginning of the loop. It's going to make it loop again. So all this looping is doing for us is it's going from 1 till 10 and outputting that. But if you look here, if it's 4, then you continue. So you never hit this output statement. You see, it's got all these numbers in here except 4. Because when 4 came, it went to the beginning. Now, if you want to... What do you think is going to happen? I told you break is going to come out of the loop. Let's run. 3. And as soon as it hit 4, it broke out of the loop. Right, so those are it for the switch, the control structures. Okay, let's go ahead and get started with the functions piece of things, right? Not the chapter, but the what functions are, how do we go about using them, what's the point of them, what's the advantage of them. So a function is a block of code that performs a specific task. Well, you can say that it's true for any lines of code. But you'll see how functions are slightly different than your other lines of code. Now, dividing a complex problem into smaller chunks is going to make it easier for you, all right, and also someone who's going to troubleshoot your code that you write. If you come across a situation where you're having to write the same line of code over and over again, well, that is a great candidate for functions. Okay, so you're going to take that line of code or lines of code that you seem to be repeating over and over again, and you're going to make a function out of it, and you're going to call that function. So let's say you've got 5 lines of code that's repeated 3 times. Now
You're gonna make a function out of it, and instead of repeating those 5 lines again and again, you're just gonna call the function. There are two types of functions. One is a function that you define, which is called a user-defined function. Then there is a functions that come as part of importing a library. stdio is a library in C that you import. Math is another library that you import. And once you import a library, it comes with a set of defined functions that you can use that are available to you, which is all fine and dandy. But for the sake of this lecture and how the book goes about presenting it, I'm going to talk only about the user-defined function. The imported functions or the library functions that's going to be covered later. Okay, so hopefully you have the basic concept in mind now. What does a function look like? So you have your main, and you will call a function name, okay? And this is the function right there, right? So you have taken out the lines of code that you're repeating and you made a function out of it. Behind the scenes, to a compiler, the way it works is uh, once you come to this function name right here, the control, yeah, maybe I should not talk about the control, but okay. So what happens here is when this function name is called, the compiler executes these lines of code that are within the function. Now, food for thought is how does the compiler go about dealing with it? Uh, does the compiler copy paste the function code every time you call the function? Or what happens is the control goes from here all the way to here, and then the lines of code are going to get executed. Either way, think about it, uh, but the end result is the same. The lines of code and function are going to get implemented. Um, Let me talk to you about the syntax of the function. You saw it, right? You have a return type, the name of the function, and the arguments, right? Now, there's no min or max arguments that a function can take. A function can take in 0 arguments. A function can take in 50 arguments. But I've never seen it more than 10 arguments is also pretty high, but I think I've seen, yeah, at most 10, probably 7 maybe, but not as many. Yeah. Um, and so you return type, function name, argument one, argument two, and then then you get the body of the function. Let me walk through some of the examples. I've got a few examples here. Now the different flavors of functions that I'm going to show you is, well, let's show you the function first, and then we'll get into the different flavors. Here I've got a function that takes in two numbers, two integers. It's going to add them and then return the result. It's going to ask the user for the input. Enter 1, enter 2, well, the sum is 3, voila. There isn't a whole lot of, actually there is no error checking in here. So the sum is 3. And how does the program go about executing this? So you've got 3 integers defined, n1, n2, and then you get the sum. And then I ask the user for 2 numbers, and then I call add number with n1, n2, and then whatever it returns, I store it in sum. Alright, so this is the method right here. It's a function definition. Int result. I declare another integer, and result is equal to a plus b. See, I'm not doing any error checking in here. And then I return the result. So what's going to happen is a and b in this case, a is 1, b is 2, and then result is uninitialized, and then I say a plus b, which is 3, so result becomes 3, and then that's what I return. And then when I return, I've got a sum here, and so that sum is equal to 3. Okay. Another example. this example, what I want to show you is a function can return nothing, and if a function returns nothing, it's void. You have to give it the keyword void. You cannot just skip the return keyword. So you couldn't have said just check prime number. Right? You have to tell it if it's gonna return something or return nothing. In this case, is void. And this method, this function, doesn't take in anything either. Right? Straightforward and simple. So in my main method, all I do is I'm saying check prime number. Okay, void check prime number. I haven't passed in anything. Then I've got three integers, n, I, and a flag that's set to 0. And then I ask a user to enter in a positive number. I take in the positive number. If it's 0 and 1 are not prime, right? So if it's equal to 0 or if it's equal to 1, then it's true. Otherwise, what I do is I go from, start from 2 all the way I less than or equal to n divided by 2, and then I increment I. And then I do this modulus. The modulus operator is another built-in operator. You can use it as a mathematical operation. If the modulus returns 0, right, that means flag is 1. Otherwise, you break. So as soon as you found out that the number is a prime number, break out of the loop, and then that's it. And then you go over here. And then you say flag is 1, you say that number is not a prime number. Otherwise, that number is a prime number. And we all know what is a prime number, right? So I'm going to pause there, and what is a prime number? I hope you guys know this, right? A whole number greater than 1 that cannot be divided by any whole number other than that itself, right? Let's go ahead and run it. So if I do 0 and 1, 0 is not a prime number. 1. So if I do 0 and 1, this is what happens. Alright? And then if I say 99, 99 is not a prime number, right? So that's how it goes about deciding it using the modulus operation. So doesn't take in any parameters, doesn't return any parameters, yet the work is done within the method itself. Okay, what do I got next? Get integer method. Okay, it's not taking in any argument, but it's gonna return something. Okay, so I've got 3 variables in there, n, I, and a flag, and then I say get integer. All right. So I enter a positive number, I take in, and then I return that number. Simple as that. Now, what I'm doing is I'm actually checking if it's a prime number or not. So I have the input is being delegated to a method. So I've created this method get integer that's getting called. Right? That's getting called, and all it does is takes the input from the user and returns that number. And then the rest of the work, which is the calculation or finding out if it's a prime number or not, is getting taken care of outside. So it's similar, right? For 0 and 1, it's not a prime number. And if it's, I'll use the same example, 99, it's not a prime number. How about a 100? 100 is not a prime number either. So the concept is same. We want to check if it's a prime number or not, but we're going about it different ways. Moving on to another example. In this one, so in the last one it returned something, but it didn't take in anything. In this one, we're not going to return anything, but we are going to take in an integer. Now you can guess what's going to happen. We are going to ask the user for the input, and then send in that input to the prime number method. And the prime number method is going to go about um, calculating, I should say calculating, but finding out if that number that's being sent in as a parameter, if it's a prime number or not. Still the same. It's the same code that I've copy pasted it. So we've seen a method that takes in nothing and returns nothing, right? A method that returns something but doesn't take in anything. This one, it doesn't return anything but takes in something. What's going to be the last type of function? A function that's going to take in something and also return something. Right? Enter a positive number, and I send in the positive number. And it does its calculation. It either returns what is it? It returns 0 or 1. Yeah, I was looking for that 0 because 0 is false, 1 is true. So it's either going to return 0 or 1, and then I'm going to output if flag is equal to 1. It's not a prime number. If probably if flag is 0 at that point, then it is a prime number. 37. Right, 7 is a prime number. And this is I was able to find the prime number. So it really depends on how you want to write the function. It's user defined, you define it, but you got to be careful, right? Are you going to take in something? Are you going to return something? The number of arguments, the syntax, etc. That's all done by you. Oh, one thing to keep in mind is when you name, the name that you give a method is very important because make sure you give it a name that makes sense. Don't, like this method is checking for prime number. So I called it check prime number. So don't give it like, what else? You could have called it my favorite method, right? So I could have called it my favorite method, but when someone else comes to it, it's like someone's trying to troubleshoot it. Someone else, like I've written this code today, 5 years down the line, someone else comes and look at my favorite method. What is it doing? So he's gonna get confused. But if you give it a meaningful name, it's gonna be easy. On this topic, the functions topic, the last thing I wanted to cover is the advantages of functions. Okay, so the program's easier to understand, and you can maintain and debug the point that I just mentioned. Reusable code. So you've got a method that can be used again and again. So you reduce the line of code, and when you've got a reusable method, you can even use it across classes, across files, and it's got a whole, like when I go into a team, I look at the reusable components, reusable method, and that's how I go about writing method. My program, I mean. A large program can be divided up into smaller modules, so it's broken up. So you've got a large program, you divide it up into different segments, and then you give it to different people to work on. So you can have multiple people working on the project, hence reducing the number of times, the number of time it takes to complete the whole program. Okay, hopefully that made sense. That's enough for this lecture. I'll see you guys. I'll talk to you next lecture. Take care.